Good evening, everyone. Welcome back to third lecture of linear algebra. Okay, yesterday we have seen subspace and some examples. I'll just recall recall theorem which says how to prove a given subset is a vector space. Okay, like we have a non-empty set W. Theorem you can see, right? W of a vector space V is said to be subspace. Is subspace if and only if alpha u plus v belongs to W for all alpha belongs to F for all u comma v belongs to W. It is also equivalent to saying that u minus v belongs to W for all u comma v and alpha u belongs to W for all alpha belongs to F and u belongs to W. So any one of these properties satisfies, we can say that W is a subspace. And also another, we also yesterday one of you told that W is a subspace if and only if alpha u plus beta v belongs to W for all alpha beta from F, u comma v from W. So that is also equivalent. Both all are equivalent. So we have seen some examples, and I have given exercise. I don't know whether you are verified or not. This one, did you check or did you try to see that by calculating this, you will not get alpha Z1 plus Z2. Did you check this one? W4. Okay, if you don't do, then verify once again. And W5 is also vector space. I told you because it is linear homogeneous equation in XYZ. So it is a vector space. I have given proof here. So later you can go through this proof. Okay. And then W6. W6 is XYZ belongs to R3. So such that the matrix, some matrix which I am calling A into XYZ equal to 0, 0. So this is a set. That means set of all vectors XYZ satisfying this equation. You see this matrix multiplication is nothing but we are taking 3 equations, right? We are taking 3 equations. Can you tell me what are those equations? X plus 2y plus 3z equal to 0, 2x minus 8y plus 9z equal to 0, 2x plus 3y plus 4z equal to 0. So this matrix multiplication is nothing but linear equations only. It is a homogeneous linear system of homogeneous equation. Homogeneous linear system of equations. So we can easily prove that it is a subspace by using the definition. Like I take x is equal to x1, y1, z1, and y is equal x2, y2, z. Here I am taking as a row vector, but when you multiply with matrix, we need column. That's why I am writing x is equal to x1, y1, z1 transpose, y is equal to x2, y2, z2 transpose. Both are in W6. W6, you see this W6 I am writing in a matrix form. X is equal to xyz transpose belongs to R3 such that AX is equal to 0, right? This is xyz is 0, right? AX equal to 0. 0 is 0 vector, X is a vector in R3. So if you take xy in W6, we have to verify that alpha x plus y is in W6 or not. How do you verify alpha x plus y is in W6? We have to show that A times alpha x plus y should be 0. Right? So A times alpha x plus y. So this by using matrix operations, we can see that alpha times AX plus AY. AX is equal to 0. Why AX is equal to 0, students? Sorry. Chapandi, why AX is equal to 0?
By our condition.
By our rule. X is from W6, right? X, Y are coming from W6. So in W6, AX should be 0 and AY also should be 0. So that's why A alpha into 0 plus 0, which is equal to 0. So that means if you get A times alpha x plus y equal to 0, which implies alpha x plus y is in W6 because that is the rule for W6. So if it is satisfied this kind of property, then we can see that W6 is a subspace of R3. Okay. So now, so these are examples for vectors in R3. Now we will see subspaces for matrices. Okay. So we know that set of all matrices of fixed order is a vector space with respect to usual operations, right? So we will see some examples in the space of matrices. Okay, example, which example this? 1 minute. Okay. Let V equal to M 2 by 2 of R. So set of all 2 by 2 matrices with entries R, where it is a vector space over F is equal to R. We know that this is a vector space, right? It's a vector space. Yeah. Now we have to see which of the following are subspaces of which of the followings are subspaces. Followings are subspaces of V. Okay. So I will write one by one. You have to tell me. A. W1 equal to set of all symmetric matrices of order 2. Symmetric matrices of order 2. So what is this one? Do you know what is a symmetric matrix? Symmetric matrix means A equal to A transpose. A equal to A transpose. Set of all A such that A equal to A transpose. So is it a vector space? Is it a subspace of V? Tell me. You know about transpose operations, right? Yeah. Excuse me, if someone can answer. Is it a subspace?
Yes, sir.
Suppose A is equal to 1, 4, 6, 5, 6. What is the A transpose?
1, 5, 4, 6.
1, 5, 4, 6. Okay. So this we know. We know A transpose definition. So set of all symmetric matrices of order 2. Is it a subspace of V? V is 2 by 2 matrices. Set of all 2 by 2 matrices. Okay. It is a subspace. How do you prove? How do you prove? We take let A comma B. We have to use the theorem. Okay. Let A comma B in W1.
Alpha A plus B.
Yes. And alpha is real number. Then we have to take alpha A plus B. We have to see this alpha A plus B is in W1 or not. So to check what we have to see whether it is a symmetric or not. That means we have to find out the transpose. Then we will see whether transpose is itself or not. So what is alpha A plus B transpose? By using
alpha A transpose plus
yes, alpha A transpose plus
B transpose.
yeah. Alpha transpose plus B transpose.
B transpose.
And A, B are coming from W1. That we should remember. So A transpose is what? A. And B
Plus B.
is B. So we are getting alpha A plus B transpose is equal to 1. A comma B are from W1. Okay. So alpha A plus B whole transpose is equal to alpha A plus B. So that means alpha A plus B is in, it is a symmetric. So alpha A plus B is in W1. W1 is a subspace. Okay. Now, one thing you have to remember, is it a non-empty set? First, we have to see whether it should be non-empty set. Just satisfying this property, we cannot say. So can you give me one vector which is symmetric, not vector, matrix, which is symmetric matrix of order 2. So W1 should be non-empty.
1, 1, 1, 1.
Identity.
Identity.
0, 0, 1.
1, 1, 1. So we can give. So it's non-empty. W1 and here comma and W1 is non-empty. That's why it is subspace. Great. Next, W2, another subspace set. Set of all invertible matrices of order 2. These are standard examples, students. Okay. Sorry, I'm calling students. You're not students. Set of all invertible matrices of order 2. చెప్పండి ఇది ఏమవుతుంది? ఇది వెక్టర్ స్పేస్ అవుతుందా? ఫస్ట్ ఆఫ్ ఆల్ ఇది నాన్ ఎంప్టీ సెట్టా?
Yes, sir.
Yes, sir.
Because 1 0 0 1 is there, it's non-empty. Now we
Right.
will see whether it is a subspace or not. If A, B are invertible అయితే alpha A plus B invertible అవుతుందా ఇప్పుడు?
Alpha not equal to 0.
Alpha is not equal to 0 still. Suppose A, I will take A and B equal
Is
to
not
alpha
a
equal to
subspace,
minus
sir.
1. Huh?
It is not subspace, sir, because a zero vector does not contain inverse element.
Yes, zero
Okay.
vector. So we know what is a zero vector with respect to usual addition in set of all matrices, zero matrix.
Zero
All
matrix.
zero. If all entries are zero, then determinant is zero. So when a matrix is invertible, we know that a matrix is invertible if A belongs to M2 by 2 is invertible if and only if invertible if and only if a determinant of A is not equal to 0, right? So this why 0 0 0 is not there. So simply we can say that zero matrix 0 0 is does not belongs to W2. So it is not, W2 is not subspace. Because why 0 0 is not there in the W2, in the subspace W2? Because determinant of this is 0. So it is not in W2. Okay. Good. Next example. W3 equal to set of all skew symmetric matrices. Of order 2. So how do you define which is equal to set A such that A belongs to, which is equal to set of all A such that A transpose. What is a symmetric matrix? How do you define?
A equal to A transpose.
Skew symmetric. A transpose is equal to
minus A.
minus A.
Right.
The diagonal elements are 0 0.
Automatically, if you write this property, A transpose is equal to minus A, automatically diagonal entries are 0 0 0. But it's a property of skew symmetry. So is it a subspace?
Yes, sir. It is a subspace.
It is a subspace. Same argument. అలా మన సిమెట్రిక్ మ్యాట్రిసెస్ ఎలా ప్రూవ్ చేస్తామో ఇది కూడా అలా ప్రూవ్ చేయొచ్చు. చేస్తారా అండి ఇది? లైక్ ఏ బి ఉన్నాయి అనుకోండి W3 లో. Let A comma B belongs to W3.
Sir, we will do, sir.
Yeah, you will do.
Yes,
Okay,
sir.
next.
Leave it.
గ్రూప్ లో డిస్కస్ చేస్తారు సార్, గ్రూప్ లో పెట్టేస్తారు అవసరం.
Okay.
Yes, sir. చేసుకుంటాం సార్ ఈజీగా.
ఓకే సార్.
Okay. So next W4. Set of all scalar matrices of order 2. W4. These are all standard examples I want to write. W4 equal to set of all scalar matrices. Scalar matrices అంటే తెలుసా అండి? Okay, I will write.
Diagonal matrix is equal to 1.
Diagonal matrix which are same diagonal.
No, diagonal matrix same, sir.
All entries, it is a diagonal set of all diagonal matrix whose diagonal entries are same. So like diagonal set of all it's a scalar matrix. So which is equal to it's odd equal to 2 by 2 I said.
It is a subspace, sir.
It
There
is
is a
because set of all A. Okay, set of all. How do you define this one? Set notation A0 B. A0 B P. A0 A. Such that A belongs to R. So it is, we can prove that it is a vector space. You check. Okay. In general, n by n matrices to scalar matrix and it is a diagonal matrix. Set of all diagonal matrices whose diagonal entries are same. Means A undalanna diagonal lo migitha elements ani 0 undali. Okay. Next W5.
For an order n also it satisfies us, sir.
Yes, every
in all
order.
problems.
So every order. So
Okay.
order n also it is true. It is a subspace. You verify. Okay. And the next W5, set of all diagonal matrices. Is it a subspace? And okay, you verify this one. And F, it is a subspace, and you verify W7, W6, sorry, W6, set of all upper triangular matrix.
Subspace, sir.
Yeah, it is also subspace. And set of all lower triangular matrix.
It is also same subspace, sir.
Yes. We will see later. We will come back to this matrices, this spaces. W8, set of all singular matrices. What about this one? Singular matrices. Singular means determinant of A is equal to 0.
It's not set, not a vector space.
Can you give me one example? Why it is not a subspace? Can you prove? Give me counter example. Which property does not satisfy?
It is zero space, sir.
matrix.
Huh?
Zero matrix does not
Zero
exist, sir.
matrix.
0 is there. Why it is not a subspace?
Yes, that does not.
Determinant of ABCD is, we know, no? Determinant of ABCD, AD minus BC. So 0, 0 determinant is 0. And you can take, for example, you take A is equal to 1, 0, 0.
Scalar multiplication not satisfied, sir.
Scalar multiply, if you take a matrix non-invertible, if you multiply with alpha, it is also non-invertible. It is not closed under vector addition. 0, 0, 0. Now you take this one. Alpha is equal to 1.
But singular matrices inverse does not exist.
Yes, that's true. So what? Why it is not a subspace? Singular matrix inverse exist కాకపోతే subspace కాకూడదా? మనం ప్రూవ్ చేయాల్సింది ఏంటంటే ఏదైనా ప్రాపర్టీ సాటిస్ఫై కావట్లేదు. ఇక్కడ చూడండి, A ఈక్వల్ టు ఏం తీసుకున్నాను, 1, 0, 0, 0, and B is equal 0, 0, 1. See, A, B are belongs to W8 because it's singular matrices. When I take A plus B, it is not determinant of A plus B equal to what?
Sir, not equal to 0.
Not equal to 0. So it is invertible. That means A plus B does not belongs to W8.
Sir,
So that way, okay?
not a vector space.
Yes.
A
So,
not equal to.
yes. So W8 is not a subspace. So we may have two singular matrices, but some may not be singular matrices. Okay. Next, another one. Set of all W9, set of all A belongs to M2 by 2 of R, such that determinant of A is equal to 1. So this one. So you have to see whether it is closed under scalar multiplication or vector addition. Both you have to see, no?
It is not closed.
Yeah, with respect to what? Under what?
Addition.
Addition, yeah. So,
Product. Closure property is not satisfied, sir.
yes, yes. So how do you say that one? You have to give counter example, no? You have to give A, B, and A determinant of A, B is not A plus B is not in this thing. So A is equal to B equal to what you are taking, then what?
A not equal to 0, B not equal to 0.
Not equal to 0 means determinant is not equal to 0. No, you have to give two matrices whose determinant is 1, but when you add A plus B, that determinant of A plus B should not be 1. Appudu A plus B untundi, A plus B, A untundi, B untundi, but A plus B undatledu. Andukane appudu closed kaadani cheptam. Is that clear?
1001, 1001 again.
Yes.
Unit matrix, second order.
A plus B does not belongs to W9. Okay. So I think we can zero vector లేదు కాబట్టి డైరెక్ట్ కూడా చెప్పొచ్చు W9 is not a vector space. Okay. So this W10. Another one, last one. There are two more examples in the matrices. W10 equal to A belongs to M2 by 2 such that AB equal to BA, where B is fixed matrix. Where B is a fixed matrix. So what can you say about this? You verify this one. Tomorrow you will tell me. Okay. And another one, verify. Verify means it is a vector space. You have to tell me. K, vector subspace. Another one, last. A belongs to M2 by 2 such that A square is equal to A. So what do you call matrices which satisfy this property A square is equal to A? Idempotent. Set of all idempotent matrices. Yeah, these two you have to tell me tomorrow. Okay, I will leave it as an exercise. Okay, and this is all about matrices. Okay, now we will see subspace in space of functions. Example, another example. We'll take V equal to, example, let V equal to f of x comma r, where x is non-empty set. Did you remember what is this? What is this f of x comma r? Did you see yesterday class? Integer f of x comma r, set of all real valued functions defined on x. Okay. So we know this is a vector space with respect to usual operation. If you take f comma g two functions, then f plus g is also function f plus g of x is equal to f of x plus g of x, and alpha fx is equal to alpha into f of x. That is a scalar multiplication. I have defined yesterday. Yesterday I have defined this. I'll show you. Yes, with respect to f belongs f of x comma r such that f of a is equal to 0. Here a belongs to x fixed, capital X fixed. Okay, and B problem. Tell me with okay, I will write all B. W2 equal to f belongs to f of x comma r such that f of a plus f of b equal to 0, where a comma b are fixed elements in x. W3 is equal to set of all f belongs to f of x comma r, f of a into f of b into f of b equal to 0, where a comma b are two distinct elements in x, are distinct elements of two elements of x. D. W4 is equal to f x comma f. Sorry, f belongs to f of x comma r such that f of a plus 2f of b equal to 0. Okay. So tell me which of these are subspaces?
C is not subspace, sir. Remaining are subspaces.
A is not a.
C is not.
C, yeah, C is not a subspace and remaining are subspaces. Why C is not a subspace? Can you give me a counter example? Which property does not satisfy? Did you work out or you are guessing?
Guessing, sir, not linear in form.
Yes. There are product, right? So that is a good observation, but we have to give example also. Okay. So example is, first one we can verify. So you take first one, second one, these are subspaces. You want proof of this, you have to see that F, for example, W1, if I take, I will prove first A. You take two functions. F comma G belongs to W1. So I'm taking W1, okay? F comma G belongs to W1. And alpha is real number, because here we are taking it as a vector space over real numbers. So we have to see alpha F plus G, whether it is in W1, W not, W1, it is in W1 or not. What is W1? W1. W1 is set of all functions as that f of a equal to 0. So if you want to see whether it is in W1 or not, you have to evaluate this function at A. Which is equal by using operations alpha f a plus g of a. So alpha f a is alpha times f of a plus g of a. And what are f and g? F and g are coming from W1. So f of a is 0 and g of a is also 0. So which is 0? Alpha f plus g of a is equal to 0. It is satisfying the rule of set. So it should be in the set. Alpha f plus g should be in the set W1. So it is a vector space. It is a vector subspace of f of x comma r. Similar way we can prove others also, but C is not a subspace. Why? I'll give an example. Verify C, B and D. So now we'll give a counter example for C. It is not closed under vector addition. For example, you take f of f defined by f of x is equal to 0 if x is not equal to a, and 1 x is equal to and g of x is equal to 0 if x is not equal to b, and at x is equal to b, it is 1. So tell me whether f is in W3. F is in W3 because you see f is in W3 because what is f of a? F of a is 1. What is f of a? F of a is 1. And what is f of b? We will write here f of a is 1 and f of b, because x is not equal to b, b is not equal to a, because a, b are distinct. So f of b is 0. So f of a into f of b is 0. So f is in W3. Similarly, g is also in W3. Right? Now, if we calculate g of b is 1, g of a is 0. Yeah. So now we will calculate so what is f of g? F plus g we have to calculate, no? F plus g. Yeah. So we'll calculate f plus g whether it is in space or not. F plus g f plus g of a. What is f plus g of a? What is f plus g of a?
1.
1. And f plus g of b? It is also 1. So f plus g of a into f plus g of b. Equal to 1 into 1, which is 1, not equal to 0. So f plus g is not there in W3, I think W3. So f is there, g is there, f is in W3, g is in W3, but f plus g is not in W3. So it is not closed under vector addition. So it is not a subspace. Is that clear? Okay. So if you have any doubt, you can ask me later. And there are some other
Question
examples.
B 160.
B. Yeah. Okay. Did you verify this?
Okay, sir. They can do
Okay.
in.
Option D equal to 1 unte not subspace, sir.
Which one?
Option D low is equal to 1 unte not subspace, sir. Zero vector
Yes,
not.
yes. If it is f of a plus 2 f of b equal to 1 unte, W4 is not a subspace. Yeah, that is we can verify. Because it is now it's kind of non-homogeneous equation. So if you have a non-homogeneous equation, it is not a subspace. Okay, some more exercise I will give tomorrow in this subspace about these function spaces. So now we will see another new notion, linear combination. Linear combinations. Linear combinations. Let definition. Let V of f be a vector space over f, be a vector space. Whenever I write V of f, that means it is a vector space over the field f. Okay, that you have to understand. A vector u belongs to V is said to be linear combinations of vectors v1, v2, v3, so on vn, v1, v2, vectors v1, comma v2, so on vn in V if there exists scalars, alpha 1, alpha 2, alpha 3, so on, alpha n in F such that, so when you say U is a linear combination of V1, V2, V3, so on Vn, if there exists scalar alpha 1, alpha 2, alpha n such that U equal to alpha 1 V1 plus alpha 2 V2, so on alpha n Vn. So this we can write in the summation form, summation alpha j Vj, j is running from 1 to n. Okay. So we have initially V1, V2, V3, Vn. Then you multiply alpha 1, alpha 2, alpha n with this V1, V2, Vn, and then add. Then that we call linear combination of alpha V1, V2, so on Vn. Okay. So different alpha j's, you will get different linear combinations. We will see some more examples about this linear combinations. First example we will see. Example. So let V is equal to R3, standard vector space. It's a vector space over R3, we know. And now we can see that 4, 7, 1. I'm going to give you an example. 4, 7, minus 1 is a linear combination of 1, 2, minus 1 and 2, 3, 1. Why? Because since we can see here, we can easily verify this with simple calculation. 2 into 1, 2 minus 1 plus 1 into 2, 3, 1. You see, if you multiply 2 with this first vector and 1 with the second vector and add those, you will get 4c minus 1. So here V1 is 1, 2 minus 1, V2 is 2, 3, 1, alpha 1 is 2, alpha 2 is 1. So because of we can say that 4, 7 minus 1 is linear combination of 1, 2 minus 1, 2, 3, 1. Is that clear? Now we will see another example. So let V equal to R3 of x, square bracket x. This also denoted P3 of f, P3 of R, real lines. That means what is this? Do you remember? What is R3 of X? What is this notation for? Set of all polynomials of degree at most 3. You have to remember this standard notation. Okay. Set of all polynomials of degree at most 3 over real numbers. Degree at most 3 over R. That means coefficients are coming from R. So it is a vector space, right? So I'm taking one vector in this vector space, x cube plus 3x, x cube plus 3x minus 2. So we can see that it is a linear combination of 1 into 3x square plus 2x minus x minus x minus x plus 2 minus 2 into x cube plus x square minus 2x plus 2. So we can see this, if you multiply this 2, you will get this, right? Multiply 1 with the first polynomial, multiply minus 2 with the second polynomial, and then if you add it, you will get this one. Okay, we can verify, right? So that's why we can say that x cube plus 3x minus 2 is a linear combination of these two polynomials, P1, P2. Okay. Another example. So so how do you verify? Suppose if I give, we'll do one problem before that. First, we will see some another definition also. We'll give some more problems. Okay, don't worry about the problems. Be clear with the definitions. And V is equal to, we'll take M 2 by 2 matrices. 2 by 2 matrices and 1, 2, 3, 4. Matrix 1, 2, 3, 4. One, two, three, four. So 1, 2, 3, 4. We can now I'm taking matrices. We don't write the coefficient now. 1, 0, 0, 1 plus something into 0, 1, 0, 0 plus something into 0, 0, 1, 0 plus something into 0, 0, 1. So can you tell me what should be the first scalar? 1. I have already written. What is the second scalar? Something with the second matrices. What is the second scalar? 2, right? And what is the third scalar? 3. And fourth scalar? 4. You see that? So 1, 2, 3, 4 is a linear combination of these 4 vectors. 1, 0, 0, 0, 1, 0, 0, 0, 0, 1, 0, 0, 0, 1. So we can say that 1, 2, 3, 4 is a linear combination of these 4 matrices. Okay. So that is the definition. I have given this example to understand the definition, to digest the definition. So now we will define another notion, linear span of a subset. Linear span of a subset. So similarly here we will take V of f as a vector space. V of f, let V of f is a vector space. Okay. So a subset, linear span of a subset of, okay, S is subset of V. S is subset of V. Linear span of subset S. Subset S is denoted by span of S. Notation is span of S or L of S. These are the notation, standard notation. Some people use span of S, some people use L of S, some textbook use L of S. And defined by, how do you define this one, span of S? Span of S equal to the set of all bracket finite linear combinations of vectors in S. Okay, S is subset of F, V, subset of V. That means S has some vectors. You take all finite linear combinations of vectors in S, that you make a set. That set we are calling span of S. S lo una vectors anni disకొని వాటి యొక్క linear combinations find out చేయాలి, all possible linear combinations. చేసిన అన్ని ఒక సెట్ లో ఉంచితే ఆ సెట్ ని స్పాన్ ఆఫ్ ఎస్ అంటాం. ఓకే, we will see some properties of this one. We can verify this. Okay, in the set notation also we can give this is in verbally I have said. In the set notation, summation j is running from 1 to n alpha j vj, where n is a integer, alpha j's are scalar, and vj's are yes, for s j is equal to 1 2 3 so on n, j is equal to 1 2 so on n. Okay, so you have to take collection of summation of alpha j vj. You have to change alpha j's and vj's. You have to change alpha j's from the field, vj's from the subset s. Okay, so this is called, yeah. So we have ఇక్కడ ఉన్న ఆల్ఫా జేస్ అన్ని స్కేలర్స్ అన్ని ఎఫ్ నుంచి తీసుకోవాలి, విజే వెక్టర్స్ విజేస్ అన్ని ఎస్ నుంచి తీసుకొని ఇలాంటి లీనియర్ కాంబినేషన్ ఆల్ పాసిబుల్ లీనియర్ కాంబినేషన్ తీసుకుంటే వచ్చే సెట్ ని మనం స్పాన్ ఆఫ్ ఎస్ అంటాం. ఓకే, ఇక్కడ ఒకటి కన్వెన్షన్ ఏంటంటే we also define if set is empty, that means L of empty set, span of L of empty set. Okay, I'll write as a theorem. First one, L of empty set is equal to 0. So this is a convention, Andy. So if non-empty, then we use the above definition. If it is empty, we have to straight away say that it is 0 vector. Okay, this is our convention. And the second one, and L of S, sometimes they will ask what is L of S. They will say, they will give different definition for L of S in the objective type also. L of S can be thought of the smallest subspace of V, smallest subspace of V which contains S. S subset గా ఉన్న అన్ని సబ్స్పేస్ లో L of S అనేది ఒక సబ్స్పేస్ అవుతుంది, అది స్మాలెస్ట్ అవుతుంది. ఓకే, L of S is the smallest subspace of V which contains S. Third one, span of S is the intersection of is the intersection of W. Okay, intersection intersection W of L of S is the intersection W of all subspaces V of subspace of V which contains yes. So we'll take subspaces of V which contains S. S subset గా ఉన్న అన్ని సబ్సెట్స్ తీసుకొని వాటి ఇంటర్సెక్షన్ తీసుకుంటే వచ్చేదే L of S. Okay, intersection of all subspace of V which contains S. Okay, so this is another way of understanding L of S. L of S is the smallest subspace which contains S, or L of S is the intersection of W intersection of all subspace of V which contains S. Okay, so this is the theorem, and we have some notes. So sometimes span of S or L of S is called subspace of V spanned by S. It is called subspace of V spanned by S. This is the terminology. Okay, you should remember this. In particular, if S is equal to V1, V2, V3, for example, if S is equal V1, V2, so on finite set, V2, so on Vn. If S ఇలా ఉందనుకోండి, then span of S name అంటాం, span of S or L of S is called subspace of V spanned by vectors, subspace of V spanned by vectors V1, V2, so on Vn. Yeah. Okay, so here we are doing problems. Let W1, W2 be two subspaces of V. Then which of the following is correct? You have to tell me. 1. W1 union W2 is a subspace. 2. W1 intersection W2 is a subspace. 3. W1 minus W2 is a subspace. Yeah, and yeah, none of this otherwise. So can you guess what is answer? W1 union W2 can be subspace.
No, sir.
So here it is set minus. Maybe I will write set minus. W1 minus W2 is set minus. There is another meaning, W1 minus W2. I will tell you what is that. Okay, so W1 union W2 is not a subspace. And W1 intersection W2?
It's a subspace.
Yes. W1 minus W2? It is little tricky. Can you see W1 minus W2 is a subspace or not?
Subspace.
Why? Suppose W1 equal to W2 if I take. What is W1 minus W2?
0.
Empty set, not 0.
Sir.
W1 minus W2. If W1 equal to W2, what happens W1 minus W2? The set minus, set theoretic minus. Set theoretic minus means it is empty set. So empty set is not a subspace, right? It should be non-empty. Okay. It's not a subspace. Right now. Okay, we will see why W1 union W2 is not a subspace. I will give one example. For example, W1 equal to set of all x comma 0, where x belongs to R. It is a subspace of R2, right? Do you agree? It is a subspace of R2. X-axis is subspace. Any line passing through origin in R2 is subspace. That you know. We have seen yesterday. Set of all x comma y such that ax plus by equal to 0 is a subspace. So it is a subspace. And W2 is equal to 0 comma y, y belongs to R. Is it a subspace? Yes, it is a subspace. What is W1 union W2? W1 union W2? X comma y such that x is 0 or y is 0. So that means x-axis or y-axis? X-axis union y-axis. So is it a subspace? I'm giving counter examples. Of course, it should not be a subspace because it is going to be a counter example. Why it is not a subspace? We can see that 1 comma 0 is in W1. Yes, somebody is saying something. W1 union W2. And because the y is 0, y component is 0. And 0 comma 1 is also in W1, W2. So what is the sum of this one? 0 comma 1 plus 1 comma 0, which is equal 1 comma 1, which is not in W1 union W2, because W1 union W2 lo undalante x component anna y component anna 0 undali. But here both components are non-zero. So it cannot be in W1, W2. So W1 union W2 is not closed under addition. So it is not a subspace. Is that clear? So in general, W1 union W2 is not subspace. Okay. So when W1 union W2 can be subspace?
One contained in
Subset
another.
to each other.
Yes, yes. Very good. Yeah. Let W1 to, yeah. So W1 union W2 is subspace if and only if one of R W2 is, one of W1 W2 is subset of other. Yes. Okay. Next we will see span. How to find the span. We will see some example to find the span. Okay, so V is equal to R3. We'll take V equal to R3. S is equal to E1. S is equal to singleton set E1. So you know what is E1, which is nothing but 1 0 0. I think you know this notation. E1 is 1 0 0, E2 is 0 1 0, so on. Everybody knows this one. So what is the span of S? Can someone tell me span of S? You have to take linear combinations of vectors in S. L of S is
X-axis.
x-axis. Yeah, I'm writing the definition for the first time we are doing this. So for understanding, I'm writing the definition. L of S is equal summation alpha j Vj, where alpha j is from F and Vj is from N, S, right? Yeah. So here we have only one vector in S, right? So it is equal to alpha into E1. There is alpha 1 into E1 or alpha E1. So that alpha belongs to real number. So what is this set of all, which is equal to set of all alpha comma 0 comma 0. Alpha belongs to R, set of all. So it is x-axis. So now we will take S is equal to next example. Now problem. So if S is equal to 1 0 0 0 0 1, which is subset of R3, then span of S equal to, or L of S is equal to. So answer options A. X comma Y comma 0, X comma Y belongs to R, and X comma 0 comma Y. X comma 0 comma Y. Yeah, X comma Y belongs to R, and 0 comma X comma Y. X comma Y belongs to R. None of this.
Option B is the right answer, sir.
Yes, option B. Clear, no? Because if you write the linear combination, you will get B. So X into 1 comma 0 and Y into this. If you add X into 1 0 0 and plus Y into 0 0 1, that are the linear combinations. If you find out, you will see that X comma 0 comma 1 and where X comma Y belongs to. Yes. Next.
Sir, please explain, sir.
Okay. S is we'll write L of S equal to, I'll tell you by definition. L of S is equal to, so set of, so we have to write linear combinations of vectors in S. How many vectors there in S? 2 vectors. So we have to take 2 linear combinations. Two linear combination means you have to take 2 scalars. So set of all X into first vector or alpha into whatever you take, X or Y. X into 1 0 0 plus Y into second vector. What is second vector here? 0 0 1. Such that X comma Y belongs to, you have to vary X Y from real numbers, right? This is the span. So set of all X 0 0 plus Y 0 0 Y, such that X comma Y belongs to R, which is equal to X 0 Y, such that X comma Y belongs to R. Clear? Is this clear? If you don't understand, ask me.
Okay, sir. Thank you.
Yes, yes. And next question. S is equal to third problem.
Sir, can we say this XZ plane, sir?
It is.
Can we say XZ plane?
Yes, it is XZ plane.
Okay.
Yes, yes. XZ plane. Any plane passing through origin. Okay, any plane passing through origin is a surface. So it is a plane passing through origin. So it is a surface. That also we can see. Yeah. 2 comma 0 comma 0 and 0 comma 1 comma 2 belongs to R3. Subset of R3, sorry. So what is L of S? L of S equal to, I'll give options. You have to tell me which one is correct. L of S equal to. Question is L of S equal to, then we will give options. First option is 2x comma y comma set of all 2x comma y, where x comma y belongs to R. Second option is 2x comma y comma 2z, x, y, z belongs to R. C is 2x comma y comma 2z, 2y, x comma y belongs to R. And third one is 2x comma y comma 2x, where x
B,
comma y belongs to R.
B option.
B option.
Option C is the right answer.
Option C.
Vector space. A subspace of vector space V3 of R among the following.
Hello?
Is don't tell the answers. When I ask, you have to tell the answers. Okay. You use the chat box and tell me what are the answers. X, Y, Z such that X, Y is less than 0. First option. Second option is X, Y, Z X less than 0. And C, X, Y, Z x square plus y square plus z square equal to is less than or equal to 1. D, x, y, z x plus z equal to 0. So this is a one junior lectures or DL's question. So use the chat and tell me the answer. X square. What is C here? X, y, z says that x square plus y square plus z square less than or equal to 1. So what is this? This is a ball, open ball, a closed ball, set of a sphere lopala unde solid sphere anamata. X square plus y square less than or equal to 1 అనేది closed ball antaru, then closed ball. So it is not a subspace. Subspaces are generally like planes or lines, but it is neither plane nor a line, right? It is a closed ball. But we can verify if suppose 1 1 1 suppose 1 0 0 ఉంది అనుకోండి, ఇందులో ఉంటుంది కదా 1 0 0 vector 1 0 0. So now say if it is a subspace, any scalar multiple also should be there. So I will take 2 into 1 comma 0 0. So which is 2 0 0. Is it there in this? It cannot be there, right? Because 2 square plus 0 square is equal to 4, which is not less than or equal to 1. So it is not there. So ఒక వెక్టార్ ఉందంటే ఆ డైరెక్షన్ లో ఉన్న అన్ని వెక్టార్స్ ఉండాలన్నమాట. The line spanned by that vector. Okay. So we can easily say it is not a subspace. And these are not linear. You see here xy less than 0, x less than 0. We can easily figure it out. Basically 0 vector is not there in A comma B. 0 vectors are not there. Okay, next one. Do you have any doubt? Why this B is not there? Why B is not true? So we can see minus 1 0 0 is in A, but my if I multiply with minus 2, which is equal to 2 0 0, which is not in A. So it's not closed under scalar multiplication, right? And also we can see 0 vector is also not there. That way also we can see. So what about the first one? Why first one is not a vector space? Zero vector is there in the first one. Zero vector is there in the first one. I'm asking. Okay. I think you don't want to answer. So it is not there because 0 x y, x component is 0, y component is 0, x y is 0. 0 cannot be less than 0, no? So 0 vector does not satisfy the condition x y less than 0 condition. So 0 vector is not there. So if 0 vector is not there, so it cannot be subspace. Okay. అర్థమవుతుందా అండి? మీకు ఎక్కడైనా డౌట్ ఉంటే అడగండి. ఓకే,
Okay, sir. Can you explain third example, sir? Above example.
third one. Okay, yeah, why it is a vector space. So what is this one? X plus z equal to 0. It's a plane passing through the origin, right? You have seen in three-dimensional geometry, right? Any equation like ax plus by plus cz equal to 0.
Okay. Sir, above question, sir. Not this one. Above question, sir. Above question.
C1 x square plus y square plus z square less than or equal to 1. Above question.
Above question, sir.
Question, not option you are talking.
Not option. Above question, sir. Before this.
Sir, last में doubts class. Use chat box.
Use chat box and tell me the answers. Here I am asking vector which is not in the span of S. Okay, first of all we will see what is the span of S. Then we will see what is this. Span of S is what is alpha into 1 comma 2, set of all alpha into 1 comma 2 plus beta into 3 comma 6. Where alpha comma beta belongs to real numbers. So if you write this as alpha plus 3 beta and 2 alpha plus 6 beta. Where alpha beta. So here I can take common alpha plus 3 beta. You see in the second component also we can take alpha plus 3 beta. If you take alpha plus 3 beta, what you get? So alpha plus 3 beta, if you take common, you take out common, then we will see that 1 comma 2 alpha beta are real numbers. So alpha plus 3 beta I can take as a lambda, right? It's another scalar. So alpha beta varying from R is same as I can take it as a lambda. Lambda belongs to R. So now this, so every vector either this you can write lambda comma 2 lambda, set of all lambda comma 2 lambda, where lambda belongs to R. Yeah. So you have to see a vector which is not in this. That means which is not of the form lambda comma 2 lambda. You see 5 comma 10 is of the form lambda comma 2 lambda for some lambda. Is it of the form lambda comma 2 lambda? What is the lambda value? 5. If I take lambda is equal to 5, it is 5 lambda comma 2 lambda. And the B also you see, so it is also of the form lambda comma 2 lambda. If you take lambda is equal to -3. And D, you take D. 4 comma 8 lambda comma 2 lambda. Now if you take lambda is equal to 4 lambda comma 2 lambda. So any vector of the form lambda comma 2 lambda is in the linear span. But if you see C, 4 comma 7 we have. So 4 comma 2 into 4 we should have 8. 4 comma 8 should be there. Here we have 4 comma 7. Right? So it is not option. So it is not in the span. One more thing. Here you see 1 comma span. S is given 1 comma 2, 3 comma 6. So what is 3 comma 6? 3 comma 6 is a scalar multiple of 1 comma 2. Right? So if you have a scalar multiple, then we can ignore that one because that vector anyway will come from 1 comma 2 only. We will see more details about this one. We can ignore this one. So it's simply span of 1 comma 2, 3 comma 6 same as span of 1 comma 2. When I discuss linear independent, independent and linear dependent, there you will see if some vector is linear dependent, then that we can ignore, then it will give the same span. So those concept we will see tomorrow. Okay. Okay, I will stop now. If you have any doubt, you can ask me. Okay. 2 x into 2 comma 0 0, y into 0 comma 1 comma 2, such that x comma y are real numbers. That is a span, right? Set of a linear combination. What is this? 2x comma 0 plus 0 comma y comma 2y, where x comma y belongs to R. So which is equal to 2x comma y comma 2y. So which is option? Yeah, this one. Okay, all options looks same, right? For example, you see 2x comma y comma 2z. It also looks same. You say here here z is extra, so I can take z is anything, y anything, but that is not true. Now, whatever there in the middle coordinate, 2 times of the middle coordinate is third coordinate, 2y, na? But here 2z. If I take y is equal to 0 or z equal to 1, then it is not 2 times, no? 2 times 0 is 0, it should be. So it is not the correct option. B is not correct option. Okay. Is it clear?
Thank you, sir.
Yeah.
Sir, good evening, sir.
Yes, yes.
Sir, starting problems లో నాన్ ఎంప్టీకి కండిషన్ ఒకసారి చెప్తారా సార్?
Non-empty. ఎందుకు
Non-empty
non-empty
check
ఉండాలని?
ఫస్ట్ మీరు నాన్ ఎంప్టీయా కాదా చెక్ చేయమంటున్నారు సబ్ స్పేస్ అవ్వాలి అంటే?
బికాస్ non-empty ఉంటేనే అది సబ్స్పేస్. డెఫినేషన్ లోనే ఉంటుంది non-empty అనేది.
ఎస్ సార్, ఒకసారి ఎలా చెక్ చేస్తున్నారో చెప్పారా?
Non-empty అక్కడ ఇచ్చిన కండిషన్ సాటిస్ఫై ఏదైనా ఒక వెక్టార్ ఉందా లేదా, ఆ 0 వెక్టార్ ఉందా లేదా అని చూస్తే సరిపోతుంది కదా. ఇచ్చిన కండిషన్ ఫర్ ఎగ్జాంపుల్ ఇక్కడ ఉంది అనుకోండి, ఇది ఒకటి ఉంది, W1 is equal to f belongs to f of x, r, f of a is equal to 0. ఇట్ ఈస్ ఏ సబ్స్పేస్ అని అంటున్నాం. బట్ అంతకంటే ముందు ఇది నాన్ ఎంప్టీ కాదని చూడాలి. నాన్ ఎంప్టీ అంటే ఇచ్చిన ఇందులో ఒక ఎలిమెంట్ ఉందా లేదా, అంటే ఒక ఫంక్షన్ ఉందా ఈ కండిషన్ సాటిస్ఫై, f of a equal to 0 అనేది ఉందా లేదని చూడాలి. అండ్ f of x, r ఏంటిది ఇక్కడ, సెట్ ఆఫ్ ఆల్ రియల్ వాల్యూడ్ ఫంక్షన్స్. ఓకే, సో కెన్ యూ డిఫైన్ ఏ రియల్ వాల్యూడ్ ఫంక్షన్ సచ్ దట్ f of a equal to 0? ఒక ఫంక్షన్ ఉంటుందా అంటే యూ కెన్ టేక్ 0 ఫంక్షన్ ఓన్లీ. విల్ టేక్ f of x is equal to 0 for all x, right?
Yes sir.
So that way we can see. So
Okay, sir.
Yes.
Sir, and yesterday class lo set of polynomials of exact degree n is not a vector space, but at most degree n is a vector space అన్నారు.
Yes, yes.
Exact degree కి at most degree కి డిఫరెన్స్ ఏంటి సార్?
Exact degree అంటేనేమో డిగ్రీ exponent quotient నాన్ జీరో ఉండాలి. ఫర్ ఎగ్జాంపుల్ ఇఫ్ డిగ్రీ 2 ఎగ్జాక్ట్ డిగ్రీ 2 అన్నా అనుకోండి, అందులో ఉన్న పాలినామియల్స్ అన్ని డిగ్రీ అనేది n ఉండాలి. అంటే అన్ని పాలినామియల్ exponent కోషెంట్ నాన్ జీరో. ఫర్ ఎగ్జాంపుల్ ఎగ్జాక్ట్ డిగ్రీ 2 ఉన్నది అనుకోండి, x² + 2 is a polynomial of degree 2, 3x² + 5 is a polynomial of degree 2. These are examples of degree 2. At most degree అన్నా అనుకోండి, సో at most degree 2 అంటే ఏంది, x కూడా వస్తుంది, 0 వస్తుంది, x² వస్తుంది, x² + 1 వస్తుంది, 2 simply 2 I will take k, any constant k. These are all polynomials of degree at most 2, right? Because degree ఎంత ఉంది, ఫస్ట్ దాంట్లో x లో 1 ఉంది, x² + 1 లో డిగ్రీ ఎంత 2 ఉంది, కాన్స్టెంట్ పాలినామియల్ లో డిగ్రీ ఎంత 0. సో ఇవన్నీ ఇందులో వస్తున్నాయి. అదే ఒకవేళ ఎగ్జాక్ట్ డిగ్రీ దాంట్లో తీసుకుంటే x² + 2, 3x² + 5 వస్తుంది. కానీ x + 2 తీసుకున్నాం అనుకోండి, x + 2 అనేది ఎగ్జాక్ట్ డిగ్రీ 2 లోకి రాదు కదా.
Yes sir, thank you sir.
Yes.
గుడ్ ఈవినింగ్ సార్. లీనియర్ కాంబినేషన్ లీనియర్ స్పాన్ కి డిఫరెన్స్ ఏంటి సార్?
లీనియర్ కాంబినేషన్ అనేది మన ఏదైనా కొన్ని ఫిక్స్డ్ వెక్టార్స్ ఇస్తే, ఏదైనా ఫిక్స్డ్ వెక్టార్స్ v1, v2, v3 ఇస్తే ఆ వెక్టార్స్ లీనియర్ కాంబినేషన్ తీసుకుంటే దాన్ని ఒక లీనియర్ కాంబినేషన్ అంటాం. అండ్ కలెక్షన్ ఆఫ్ ఆల్ లీనియర్ కాంబినేషన్ తీసుకుంటే అది స్పాన్ అంటాం, ఆల్ పాసిబుల్ లీనియర్ కాంబినేషన్స్. ఇప్పుడు 2, ఫర్ ఎగ్జాంపుల్ 1, 2 అనేది వెక్టార్ ఉంది. ఐ విల్ రైట్ హియర్ 1, 2, అనదర్ వెక్టర్ 3, 4. So if I want to give one linear combination of this, so I'll take -1 into 1, 2 plus 3 into 3, 4. So ide anedi if you simplify cheyachchu kada, simplify chese 8, 12, yeah, 8, 10. 8, 10 is a linear combination of 1, 2, 3, 4 అని చెప్తా simply. Okay, అది span of అంటే you have to take here -1, 3 తీసుకున్నాం కదా స్కేలర్స్. ఇక్కడ నీకు అన్ని పాసిబుల్ స్కేలర్స్ తీసుకోవాలి అంటే ఆర్బిటరీ ఆల్ఫా, ఆర్బిటరీ బీటా తీసుకోవాలి. సో యూ కెన్ రైట్ దిస్ ఇస్ ఏ లీనియర్ కాంబినేషన్. లైక్ ఇక్కడ 8, 10 is a linear combination of 1, 2, 3, 4. And if I want to say if I want to find out span of this set, say this set is S, span of S is, you have to take alpha into 1, 2 plus beta into 3, 4 set of all such that alpha, beta over R. So ఇక్కడ ఆల్ఫా బీటా ఫిక్స్ చేస్తేనేమో అది ఒక లీనియర్ కాంబినేషన్ ఆఫ్ 1, 2, 3, 4 అంటాము. ఆల్ఫా బీటా నీకు అన్ని పాసిబుల్ వాల్యూస్ తీసుకుంటే వచ్చేదాన్ని స్పాన్ అంటాం. యూ కెన్ వ్యారీ వాట్ ఎవర్ యూ వాంట్, యూ కెన్ గివ్, మీకు ఏది నచ్చితే అది ఆల్ఫా బీటా వాల్యూస్ ఇవ్వచ్చు. ఓకే, ఫ్రమ్ రియల్ నెంబర్స్. అలా ఇస్తే వచ్చిన వాటిని అన్నింటిని కలెక్ట్ చేసి డిఫరెంట్ వాల్యూస్ ఆల్ఫా, డిఫరెంట్ వాల్యూస్ బీటా ఇచ్చి ఇందులో సబ్స్టిట్యూట్ చేసి వచ్చిన వాల్యూస్ అన్ని కలెక్ట్ చేసి వచ్చిన వెక్టర్స్ అన్ని కలెక్ట్ చేసి రాస్తే అది లీనియర్ స్పాన్ అంటాం. Is that clear?
Okay, sir. Thank you.
Yes.
Sir, span of phi equal to 0, sir.
అది కన్వెన్షన్ అండి, అది మనం బై డెఫినేషన్ అలా డిఫైన్ చేయడమే. నాన్ ఎంటీ అయితేనో అలా డిఫైన్ చేస్తాం, సెట్ ఆఫ్ ఆల్ లీనియర్ కాంబినేషన్స్ ఆఫ్ వెక్టర్స్ ఇన్ ఎస్. ఓకే, ఒకవేళ ఎంటీ సెట్ అయితేనో డైరెక్ట్ గా ఎంటీ 0 అని రాయొచ్చండి. డిఫైన్ చేయడం అలా డిఫైన్ చేస్తాను.
థ్యాంక్ యూ సార్. ఇంకా ఎనీ మోర్?
Is that clear? Okay, somebody is asking. Once explain the linear combination of first example. Okay, first example, which Mamta? Okay, which example? Okay, I understood. Today class, right? This one, right? So why it is a linear combination of 4, 7 minus 1 is a linear combination of 1, 2 minus 1, 2, 3, 1. How? So if you want to verify, ikkada nenu direct ichchesan 2, 1 తో 2 into first vector plus 1 into second vector raste ఇది ఒరిజినల్ వెక్టర్ వస్తుందని చెప్పాను. ఒకవేళ మీకు ఇది ఎలా ఫైండ్ అవుట్ చేశారు ఈ స్కేలర్ 2, 1 అంటే వాట్ వీ హ్యావ్ టు డూ 4, 7, minus 1 ని ఆల్ఫా ఇంటూ 1, 2 minus 1 రాసుకోవాలి ప్లస్ బీటా ఇంటూ 2, 3, 1 రాసుకొని ఇది సింప్లిఫై చేయండి. ఆల్ఫా ప్లస్ 2 బీటా 2 ఆల్ఫా ప్లస్ 3 బీటా మైనస్ ఆల్ఫా ప్లస్ బీటా. సో ఇక్కడ ఇప్పుడు రెండు ఈక్వల్ చేయాలి ఈ 2 వెక్టర్స్ ని. ఆల్ఫా ప్లస్ 2 బీటా 4 అవుతుంది, 2 ఆల్ఫా ప్లస్ 3 బీటా 7 అవుతుంది, మైనస్ ఆల్ఫా ప్లస్ బీటా ఈక్వల్ టు -1 అవుతుంది. అప్పుడు ఇది సాల్వ్ చేయాలి. ఇప్పుడు ఆల్ఫా బీటా రెండు ఈక్వేషన్స్, ఫస్ట్ 2 ఈక్వేషన్స్ సాటిస్ఫై చేస్తే ఆల్ఫా బీటా వస్తుంది. ఆ ఆల్ఫా బీటాని థర్డ్ ఈక్వేషన్ లో సబ్స్టిట్యూట్ చేస్తే సాటిస్ఫై అవ్వాలి, అప్పుడే దేర్ ఎగ్జిస్ట్ ఆల్ఫా బీటా. అలా ఫైండ్ అవుట్ చేశాను. ఆల్ఫా ఈజ్ ఈక్వల్ 2 వస్తుంది, బీటా ఈక్వల్ టు 1 వస్తుంది. ఇలా ఈక్వేట్ చేస్తే. ఓకే, we will see some more problems. This is just for understanding I have written. We will see more example. For that we need to know system of linear equations. Okay, when I explain system of linear equation, we will do many examples about linear combinations and